The voltage and current in the primary coil of a transformer are 200 volts and 2 amps respectively. If the transformer is used to light up 10, 12 volts, 30 watts bulbs, calculate its efficiency. So we're looking for the efficiency of the transformer. Okay? Then the first thing we need to do is to, first of all, analyze the question and then know what to apply, the appropriate formula to apply. Option A is 100%, option B is 90%, option C is 75%, and finally option D is 50%. So let's go on the voltage and the current. Let's do a simple illustration of what a transformer is all about. And it goes this way. We write our solution, first of all. Alright? And then this is just a schematic representation of what a transformer is all about. If we have this side is the primary coil, alright? This side is the primary coil, while this side, okay? This side is the secondary coil. So primary coil is NP, secondary coil is NX, alright? Source, the voltage supply to the primary coil is known as a primary voltage, which is a EP, primary voltage, EP. Voltage across the secondary coil is called the EX, secondary voltage, EX, alright? And then, what next? We talk about the current. This side is called the primary current, while current this side is called the secondary current. Good. So, eventually we are going to have a connection like this, which is NEX all over NP is equals to EX all over EP is equals to IP all over IX. Okay? That is the first thing, the first relation we need to know. But the question says, if the transformer is used to light up 10, 12 volts, 30 watts bulbs, what is, or rather calculate its efficiency? It's very simple. So our analysis goes like this. 200 volts is the primary voltage, EP, and it's given as a 200 volts, alright? And then 2 amps means the primary current, yes, and that is IP is given as 2 amps, okay? And what next? Let's see. If the transformer is used to light up 10, 12 volts, 30 watts bulbs, talking about power outputs, alright? Power outputs, okay? Power output here is very simple, which is 10, 12 volts, 30 watts. That is 10 times 30 watts. And eventually this will give us power outputs, okay? Power outputs now becomes 3,000 watts, okay? That's it. So what this means is that we can now use this data EP and IP to find the power inputs, okay? Before we can now find the efficiency of the transformer, okay? Now, there is a relationship. Let's look for power inputs. Power inputs first. Power inputs is given as IP times EP, okay? So here, IP is 2 amps, okay? And then EP is 200. Good. Of course, 2 times 200 is 400 watts. So we have power input, okay, is equal to 400 watts, okay? Good, we have finally succeeded in finding the power inputs. Already, the power output is giving us this. So what we need to do now is to find a relationship that connects both the power outputs and the power inputs, and that will lead us to find the efficiency of the transformer, so said here in the question, right? Okay, that's okay. So what we need to do, we quickly clean this side since we have established what a transformer is all about and how to apply it, okay? So the next thing we need to do is to state a relationship that connects efficiency, power output, and power inputs. All right? Efficiency here is given as this is equal to power output. Power output, okay? Yes, outputs, okay? Over power inputs. Power inputs. This is power input, but I'm going to abbreviate this as time goes on. Power input times 100%. Good, 100%. So, to economize space, we can just abbreviate this to become power input. I'll write power output, P output, P outputs, okay? And then power inputs, I'll just write P input, P inputs, good, times 100%. Good, that's it. So the next thing to do, or the next step, is to substitute wisely and we find the efficiency of the transformer. Okay, this is a standard question. You can see in any of the international exams or national exams, you can see something like this. So let's go. When we substitute, substitution gives for power outputs. What do we have as power output? 3,000 watts. 3,000 watts. All right? Oh, yes. For power inputs, 400 watts. Good. And then, what happens next? Times 100%. Of course, efficiency will definitely be in percentage. Yes, it's going to be any of this percentage. All right? So I want you to do that. I want you to prove to me that you actually learned how to solve this. What do? It's already done. What you need to do is just to cancel where necessary. All right? Just cancel out. Just cancel out. I don't want to do it for you. You can cancel here, cancel there. 0, 0 goes out. 30 over 4, and then percentage. Or you quickly come here, cancel this, cancel that, and then cancel that. Whatever remains must be in percentage, all right? That's it. That is it. So let's cross-check very well. The voltage and current in the primary coil of a transformer are 200 volts and 2 amps respectively. This is okay, all right? If the transformer is used to light up 30 watts. Hold on, 30 watts should be 300, not 3,000. You see why it's nice to cross-check. This should be 300, not 3,000. Good. 10 times 30 should be 300, not 3,000, please. So this is off. One of the zeros is off. So what do we do? Very simple. Still very simple. Okay? And where again do I have that? 10 times 10 is 300 watts, and it comes down 2 times 200 is 400 watts. So we are cross-checking to see if there is any step with an error. So that is done. That is done. So if we come here, we cancel out where necessary. Just cancel out. When we cancel out, we see that this, we take care of this, okay? And we have 3 over 4. 3 over 4 will give us something necessary, something important. I want you to finish the remaining part, okay? Just press 3 over 4, whatever it gives you, right? Multiply by 100. I repeat, 3 over 4, or if you like, 300 over 400, whatever it gives you, multiply it by 100%. That is it. The answer must be in percentage. You must find any of this. So whatever you get, after doing that, put it in the comment section. Convince yourself that you have now learned how to solve a problem like this. Okay, I am signing out this moment. See you in my next class.